So this is a relative velocity problem, and we're given the velocity of car A and train T, and they want to know the velocity of the train relative to A. So that would be if you were in the car, what it looked like the train was moving as you're driving in the car. And so remember how these equations work. If you want VA, it's V train plus A relative to train. So a mnemonic to help remember that is T times A over T equals A. Or that gives us the wrong one though. We want T relative to A. So this is the one we really want. We want the velocity of the train is the velocity of A plus what the train appears to be doing relative to A. So that's what we want. Then from there, it's just vectors. And so the velocity of the train is 60 miles per hour in the x direction. The velocity of A is 45 degrees going up, and train relative to A must be coming down at some angle. Now, the way I've drawn this here, it looks like theta is 45 degrees, but that's not necessarily the case. It all depends on how the numbers come out. So I've put in the numbers. The train is going 60 miles per hour. The car is going 45 miles per hour. It's confusing. The angle is also 45 degrees. And so we need to get this vector train relative to A, VT relative to A. This is going to involve using the law of cosines and the law of sines. So I've put down here the law of sines for your review and the law of cosines. And this is easy to remember because it kind of looks like Pythagorean's theorem. Pythagorean's theorem is only true if it's a right angle. And so you can see in this case, C is less than 90 degrees, so the hypotenuse is going to be less than A squared plus B squared square root, and you have this correction factor here. So you can think of the law of cosines as Pythagorean's theorem that's been corrected for any angle, not just 90 degrees. And so it's pretty obvious we're going to have to use the law of cosines when you look at our vector diagram. And so there I've just plugged in the numbers, and it comes out to 42.5 miles per hour, the length. Now we need to get the angle to get the vector, and now we'll use the law of sine to get the angle, and that angle turns out to be 48.5 degrees.